All right, going to take what we learned from last class and apply it to the unit circle. Just to make sure we understand, the unit circle has a radius of 1. That's one of the key things off of this. Always has a radius equal to 1. Okay? The other thing that we did from last class is anytime we talk about a degree, whether degrees or in radians, we always start from the positive x-axis and we travel counterclockwise. Okay? A couple key things to remember on that, and what we're going to do is talk about how to use this to find, to graph future and to find exact values. Before we get too far, let's talk about this and just a little reminder of a few things. These are the special right triangles. The one on the left we got from a square. The one on the right we got from an equilateral triangle. Just as a review, if I said I wanted to find the cosine of 45 degrees, well, cosine of 45 is adjacent over hypotenuse. In other words, 1 over square root of 2. Okay? Which could also be rewritten as square root of 2 over 2. Okay? These are equivalent. Just as a quick reminder, those things are going to come into play. SOHCAHTOA. So let's get started. Let's first start with the positive side, quadrant 1. So if we look back here, we talk about it in 4 quadrants. This is quadrant 1 over here, quadrant 2, quadrant 3, quadrant 4. We're going to start in quadrant 1. Okay? And the very first thing is we're going to talk about what's happening at 0 degrees, and which is the same as 0 radians. Okay? At this point, like I said, we always have a radius of 1, so we end up at the point 1, 0. Okay? Radius of 1, 0. Now, for our purpose on this one, we're going to start talking about 30 degrees first. Okay? Remember, 30 degrees is the same thing as pi 6. So we have a radius of 1 at this point. Okay? A radius of 1. Now, if I drew a line straight down, and we end up with this is 30 degrees. That's what we're saying. This is 30 degrees. If I wanted to find, say, the adjacent side to this, well, I could say, well, cosine of 30 degrees is going to have to equal the adjacent over hypotenuse. But remember, our radius is always 1. So cosine 30 equals x over 1. Well, if we don't have a calculator, and that's the whole purpose of this unit circle is we don't have a calculator. Well, we can go back to this. What's cosine of 30 degrees? Cosine of 30 degrees is square root of 3 over 2. So, we can come back to this. We'll plug it in the same way. Well, cosine of 30 degrees, square root of 3 over 2, which equals x. You can put it as x over 1, but x equals square root of 3 over 2. So, this value right here is square root of 3 over 2. Okay? And realize we just got that from finding this length right here. And since we already knew what the square or cosine of 30 degrees was, it made it easier. Now, say we wanted to find y. Well, y is going to be sine of 30 degrees equals y over 1. Remember, radius always equals 1. Well, if there's only some way we could figure out what sine of 30 degrees was. Turns out we can't. Sine of 30 degrees is going to be 1 over 2. So we come back here, and it turns out this is 1 over 2. Okay? So then we go up, and I'm going to erase that 30 degrees one. Okay? Radius is still equal to 1 no matter what. Let's talk about 45 degrees. 45 degrees, or, like we figured out last class, pi over 4. Draw a straight line down here. This is 90 degrees. Once again, I want to figure out, well, how far is it x? What's my x coordinate? Okay? Well, this is 45 degrees. If I wanted to figure out what x was, I can do cosine. Cosine again. Get rid of this. Cosine of 45 degrees equals adjacent, so x, over hypotenuse, which is also 1. Can come back here. What's cosine of 45 degrees? Well, 1 over root 2. So this ends up being 1 over root 2. We want to figure out what y is. Well, it turns out sine of 45 degrees is 1 over root 2. It's the exact same thing. So 1 over root 2. Okay? This brings us to the last one. Last one in this quadrant is at 60 degrees. Pi over 3. Okay? Draw a straight line down from there. Once again, creating my right triangle. I want to figure out what x is. And I know this is 60 degrees. So I can go cosine of 60 degrees equals adjacent over hypotenuse. Well, go back to our special right triangles to make this easier. Cosine of 60 degrees is 1 over 2. Which means this is the same thing as 1 over 2 equals x over 1, or in other words, 1 over 2. Okay? If I got to find my sine of 60 degrees, in other words, my y coordinate, I'm going to do sine of 60 equals opposite over hypotenuse. Well, sine of 60, coming back to here, sine of 60 is opposite over hypotenuse. So it's square root of 3 over 2. Okay? So that handles the first quadrant, quadrant 1. And we can finish it up here once we get to 90 degrees or pi over 2. Realize we're 0 over 1. We'll talk about that in a little bit more detail later. But so far, that's quadrant 1. So we're going to move on to quadrant 2. Okay? Quadrant 1, we had all these shapes. Now, here's the first thing we need to talk about. A reference angle. Okay? Because we're going to talk about similar triangles. A reference angle. And let me draw the first one over here. If I did this one here, this is 30 degrees. Pi over 6. Okay? And I drew this triangle. Well, if I draw the same triangle of, and remember when we're doing our angles, say 150 degrees. Okay? 150 degrees gets us all the way over here. 150 degrees. Okay? Well, watch what happens when I draw this triangle. Whoa. So 150 degrees and 130 degrees. Both of them have a radius of 1. That doesn't change. I already figured out this one over here, that if I did 30 degrees, I did cosine of 30 degrees. Remember, cosine of 30 degrees is root 3 over 2. So I know this distance is root 3 over 2. And if I use sine on that one, if I use sine of 30 degrees, I get 1 over 2. So this is 1 over 2. In other words, this length's 1 over 2. We already figured that out. Well, if I go 150 degrees, look at what happens. I end up with this triangle here. This one in red, to the left. Okay? Well, how would I get this one? Well, I end up getting this angle. It's easier to actually find it from this angle here. This is what's a reference angle. Okay? it's easier for me to solve everything from that reference angle instead of using 150 degrees. I can just get it on the x-axis. So that brings up our first definition of reference angle, and it actually makes everything easier. Reference angle is the acute angle formed with the x-axis. Now the two things that are underlined are the leading mistakes. It's the acute angle, and it's formed with the x-axis, never the y-axis. Now, watch what happens. We turn this into 30 degrees here. Well, I can find sine of 30 degrees. Well, this is equal to y over 1. Well, we get the same thing as this sine of 30 degrees, 1 over 2. Okay? I do cosine of 30 degrees. I get y over 1. I'm going to get the same thing as this, root 3 over 2. But realize what direction we're going. We're now going this way on the x-axis. Therefore, it's negative root 3 over 2. So this ends up being negative root 3 over 2. So that's one of those things. If you ever plugged into your calculator cosine of 30 degrees and cosine of 150, all the numbers would come out the same. It would just happen to be negative. Okay, so let's do another one. Another one in quadrant 2. We'll go up to, we'll do this one. A little bit tougher. Okay, 120 degrees. 120 degrees on this one. Or, if you want to think of it as in radians, it's 2 pi thirds. 2 pi thirds. Okay? Now, draw our triangle down here. This is 120 degrees from here to here, which means this reference angle is 60 degrees. So, once again, we want to figure out what x is, and we want to figure out what y is. We're not going to use 120 degrees, we're going to use 60 degrees. So we're going to go cosine of 60 degrees will equal my x adjacent over hypotenuse, which is 1. Cosine of 60 degrees, come back here, cosine of 60, 1 over 2. So cosine of 60 will be 1 over 2. That's where we end up here. I do sine, cosine of 60 is 1 over 2. But because it's in the negative value, it's a negative x, negative 1 over 2. We do sine of 60 equals y over 1. Go back to here, sine of 60 degrees, opposite over hypotenuse. We get square root of 3 over 2. Okay? So, what we'll end up having you do is finishing up these ones, the unit circle on your own, to hopefully start getting the pattern. Here's the big thing I want you to realize. When we talk about the coordinates, our cosine always ends up being our x value. Our sine ends up being our y value. Okay? The last part we'll talk about today is just almost definitions. We start with 0 degrees, which is 0 radians. We said this is 1, 0. In other words, if I do cosine of 0 degrees, I'm going to get 1. If I do sine of 0 degrees, I'm going to get 0. At this point right here, 0, 1, this is at 90 degrees, or pi over 2. So same thing, if I do sine of pi over 2 or 90 degrees, I'm going to get 1. If I do cosine of pi over 2 or 90 degrees, I'm going to get 0. I go 180 degrees or pi, I'm going to get negative 1, 0. So if you actually plugged in your calculator, you go cosine of pi over 2. Sorry. Let me correct that. I do cosine of pi. Remember, this is your x value. I'm going to get negative 1. I do sine of pi. I'm going to get back to 0. And then last point here, this is 0, 1. This is at 3 pi halves or 270 degrees. And this is 0, negative 1. Sorry about the negative. Which means if I do cosine of 270 degrees, well, I'm going to get 0. But if I do sine of 3 pi over 2, which is the same thing as 270, I'm going to get negative 1.